So, what exactly is clean code? Have a look at this example. Is this clean code? Probably not. We can probably all agree that this is not clean code. It's a lot of code, hard to read, a lot of deeply nested control structures. This doesn't look very clean. Now consider this example. Is this clean code? Well, it's just one line of code, and it looks like we're calling a function, create, which creates a user named Max with an age of 31, something like this. Well, let's have a look at the entire code. This is a Python example, and in case you don't know Python, I'm defining a function here, and in that function, the lambda keyword here actually is used to create more functions, which are then returned from that function. So take a pause now, pause the video, and try to understand this code now. What is this code doing? So, did you pause the video? Did you try to understand it? And did you understand it? What we actually have here is a function, the create function, which does not create users or anything like that. Instead, it's a function which creates other functions. So it's a factory function or a higher order function. And these other functions which are being created turn out to be validation functions. We pre-configure them with a certain value, for example 31, and then we get a function which we can call thereafter to compare another value against that created value. And we either check for that value being smaller or bigger, depending on whether we chose max or min as a parameter for creating our validation function. This is absolutely not clean code, because it was very confusing, and understanding what this code does will certainly take a couple of moments. And that always is a good sign for bad code, if you have to think about it a lot to understand what it does. Because there's one thing which clean code certainly is not. It's not code that just works. The example I showed you will work. But it's still not clean code, because clean code is not about whether code works or not. Instead, it's about whether code is easy to read and understand. Because it turns out that as a developer, we spend quite a lot of time reading code, understanding code. For example, because we have to go back to code we wrote in the past to fix a bug or add a feature, or because maybe we need to dive into some code written by a colleague or by some other developer. So we need to read a lot of code. And therefore reading code and understanding code should be easy, because if it's hard, we lose a lot of time and productivity. And ultimately, entire code bases can die because no one's able to fully understand the code. So for example, here's the same example from before, now slightly rewritten. To be precise, I basically only chose different names. And now automatically it becomes cleaner. It becomes easier to read and understand. It won't take you as long to understand what's going on here as it did before. And we could of course also refactor this in other ways. We could, for example, also consider creating a class with good names and with all the validation logic baked into the class. Something like this. And of course, just to make this clear right away, there will not be a single right way of writing clean code. Instead, this is one possible solution. Using a factory function with better names would have been another solution. And in this course, we're going to dive into many possible solutions and many different concepts and rules which might apply to your specific code and situations. So what is clean code? Ultimately, it's code which is readable and understandable, and therefore code which is readable and meaningful, which reduces the cognitive load you have to go through, so that you have less cognitive load and understanding is easy. Clean code should be concise and to the point therefore, and you, for example, want to avoid unintuitive names, complex nestings, or big code blocks. You, of course, typically want to follow common best practices and patterns, and also a bunch of concepts and rules which I'm going to teach throughout this course. Because ultimately, it should be fun to write and to maintain code. And with clean code, you ensure that maintaining can be fun because your code can be understood by others. So clean code is code which is easy to understand. Dirty code is not easy to understand. And as a developer, you should therefore treat your code like a good story, like an essay. You are an author. As a developer, you are the author of your code. And you want to write it such that it's fun and easy to read and understand your code. That should be your goal, and with this course, you'll be able to achieve it because I'm going to teach you a couple of techniques and rules that help you write cleaner code. Now, when it comes to writing that essay, that good story, there are a couple of key pain points, a couple of key areas on which we want to focus and which will be the sections in this course where we will go through all the core concepts in great detail. It all starts with the naming of things, with the names we assign to variables, functions, and classes. We can already mess up code with that, as you saw with the initial example I showed you a couple of minutes ago. It continues with the general code structure and any comments we might have in the code. As you will learn in this course, code formatting matters, and there are various aspects that come into play when we talk about code formatting. And we also can differentiate between good and bad comments, and we can see how that matters and how comments, and too many comments, could actually lead to dirty code instead of improving it. Another key pain point, another important area, which we'll have an entire section on in this course, will be functions. There, it's about the length of the functions, so the amount of code in the functions and the kind of code inside of a single function, and the number of parameters a function takes. As you will learn in this course, functions are also one of the key things that leads to bad and dirty code, and therefore knowing how to write good functions is a key skill, and you will get it in this course. We also will have a look at conditionals and error handling, because nesting conditionals and control structures in general too deeply and not using error handling appropriately, these are also two common mistakes a lot of developers make, and they also lead to dirty or bad code, and doing it right, on the other hand, will improve our code a lot and will be one core building block of writing clean code. Last but not least, working with classes, objects, and data structures. That's another key area where it's easy to mess up code. It's easy to have no distinction, no separation between data structures and real objects, and we will learn what the difference is in this course, of course. And it's also easy to end up with bloated classes which are doing too many things, hence making it difficult for other developers to understand them. In this course, we're going to have a look at all these areas, at all these pain points, and we'll not just learn about the problems and the challenges there, but of course we're going to dive into the various solutions you can apply to write cleaner code. We'll dive into important rules and concepts, patterns and principles you should be aware of, and we're also going to have a look in the functions module, we're also going to have a look at test-driven development, or how testing can help you write clean code as well. Though I also want to make it clear, this is not a test-driven development course, not at all. So by the end of the course, once we went through all these sections, we'll definitely not write code like this anymore. Instead, you will know how to write clean code right from the start, but also how you can derive clean code over time as you're working on a project. Now, all these course sections in this course will follow a certain structure. We'll always start by diving into the core problems and the important rules and concepts you should know to solve these problems. For example, when we talk about naming, I will start by explaining how good names look like and why they look like this. So we'll learn about bad code and why it's bad, and we'll understand these core rules and concepts you should follow. But theory alone won't do the trick. That's why in all these course sections, I'll back that theory up with demos and examples. We'll see both bad and good code in action, and we'll also transform bad code to good code together so that we have a realistic example and we can see that transformation in action rather than me just throwing finished examples at you. In addition, every section will have challenges for you. There are challenges where you can apply what you learned, and where I challenge you to analyze and improve and transform some dirty code on your own. This ensures that you don't just learn about these concepts in theory, but that instead you get a lot out of this course and you will really remember these concepts so that you can use them in your upcoming projects. So up to this point, this hopefully all makes sense. However, you might be wondering which programming language we're actually going to use in this course. In this first example, which we transformed from dirty code to clean code, I used Python as a programming language. And indeed, you will need some programming experience, not with Python though, but in general. It does not matter at all which programming languages you are using in your projects and which other courses you are taking, but you need some basic programming experience to get the most out of this course. Because this course will not teach you how to write code, it will teach you how to write good code, and that's an important difference. Now, you don't need to be a senior developer or anything like that though. You just need some basic experience. You should have worked on some projects, but you don't need 5 or 10 years of experience, not at all. Now let me come back to the programming languages. In this course, I will mostly use Python and JavaScript/TypeScript for the examples. TypeScript simply is an extension, you could say, to JavaScript. It adds strict typing to the JavaScript language. And these are the two programming languages I will use for the examples in this course. Now, even if you don't know these languages, you will be able to follow along. You don't need to know them. I just use them because Python is very popular and a lot of people know Python. JavaScript and TypeScript, on the other hand, are quite similar to Java and C# and languages like that. That's why I wanted to include these different languages here. Now, the concepts taught will apply to all programming languages though, and if you have that basic experience which you need, you will be able to follow along even if you don't know these specific languages. You don't need to know either of these languages. If you are a C# or a Java or a Swift or anything like that developer, you will still get all the important information out of this course. Because the concepts taught in this course and the examples shown in this course apply to all programming languages. It's not specific to Python or JavaScript or TypeScript. It really applies to all programming languages. Of course, you should be able to read code like this and kind of understand it, even if you're not a Python developer. But given the fact that you should have basic programming knowledge, that will not be a problem. Because no matter if it's Python, Java, JavaScript, C# or whatever, the core ideas and things in programming languages are always the same. We have classes, objects, variables, constants, functions. This is always the same, and therefore the exact programming languages you know don't matter. You will get all the important information out of this course, no matter what your favorite programming language is. Now I got one other note about the programming languages we're using in the course and programming languages and clean code in general. In one of the first examples I showed you, I used Python. And here I used Python code which does not have any explicitly assigned types. On the other hand, throughout this course you will also see examples written with TypeScript, and for example here's a version of that code example I showed before written in TypeScript. Now TypeScript is an extension to JavaScript, and as its name suggests, the primary thing which it does is that it adds types to JavaScript. To be precise, explicitly typing things, which you normally don't have in JavaScript. And you can see type assignments here in the parameter list of this function, or also for the parameter of these return functions. Now, there are other languages, like Java or C#, which also embrace the concept of types and which also know strict typing and explicit type assignments. And then there are other languages which don't care as much, like Python, or which don't know the concept of strong typing, for example JavaScript. Now you could think that you need types to write clean code, because having these extra type assignments certainly also helps with code understandability. If you have a look at this code snippet here, it should be quite straightforward to read and understand. And whilst the types might help a little bit with reading and understanding, they primarily help with avoiding errors. And only in addition to that, they can also help with readability. But the main reason for using strong typing is that they can help prevent errors. Because I would argue that this code is equally easy to read and understand, even though we don't have strong typing here. So you don't need to use a language which knows and uses strong typing and wants explicit type assignments. You don't need that to write clean code. And throughout this course, you're also going to see a bunch of examples written in Python and JavaScript which don't use explicit type assignments. So you don't need that to write clean code. It's not a must-have. And I just wanted to emphasize this right away. Now, I got one more thing to say about the code examples you will see in this course, just to make sure that we're all on the same page and there is no confusion. All these examples which you will find in the course, and there will be many examples, are short, focused examples, always focusing on one specific concept or idea, which I guess makes sense because that is what the entire course is about. So these are code snippets and most of them won't execute. So most of the examples are just small snippets taken from a bigger fictional project, so you won't be able to run them. And I just want to make this clear so that there is no confusion. I will still show you valid code and all of that. It's just taken out of a bigger project, taken out of context. And I want to make that clear and obvious so that you are not confused why this code does not execute. The examples also don't use a particular programming style or follow a specific paradigm. I'm not doing object-oriented programming in this course. I'm not doing functional programming. I most of the time have small snippets with simple functions or classes, and what I teach you will apply no matter which programming style you are using. Now, one note for all the Java and C# developers: in JavaScript and in Python and in a couple of other programming languages as well, you don't have to wrap everything into a class as you, for example, have to do it in Java. That's why you will see standalone functions which are just defined like this without any classes in all these examples throughout the course. In Java or C#, these would simply be some methods defined in some root main class, you could say. So that's just something to be aware of. You simply don't need to have classes around everything in programming languages like Python or JavaScript. Now, as I mentioned in the last lecture, this course does not focus on a specific programming paradigm. You can follow along no matter if you want to do functional, object-oriented, or procedural programming, or anything else. Things like naming things correctly and writing good functions will always apply. Of course, you still might have paradigm-specific patterns, principles, and conventions, which you should still take into account even after finishing this course. So if the style you're using, or also the programming language you're using, has extra style guides or rules, you should of course still respect these, even if that's not covered in this course, because this course focuses on general, universal clean code rules. So of course don't abandon other rules or concepts which might apply to the style you are using. Nonetheless, the core principles and rules which are covered in this course will always apply. No matter which style or programming language you're using, it's always about using good, readable, and meaningful names. It's always about having slim and concise functions which are easy to read. And of course, you always want an understandable code flow and no deeply nested if statements. So this will all always apply, and therefore the concepts taught in this course will always apply. So we know that what you learn in this course will apply no matter which kind of code you write. But of course, you might know that there are a lot of patterns and principles out there. Some specific for a specific programming language, some specific for a specific framework, and some specific to a specific programming paradigm. How are these patterns and principles then related to the idea of writing clean code? Should you always follow them all to ensure that you do write clean code? For this, it is important to keep in mind that clean code is code which is readable and easy to understand. That is the main thing you have to keep in mind when writing clean code. Now, all these patterns and principles out there are focused on ensuring that you write code which is extensible and maintainable. Of course, there is a connection. Of course, if you follow these patterns and principles, that can help with writing clean code. On the other hand, if you name things poorly, if you format things poorly, if you have functions which are super clunky and messed up and hard to read, you can follow all these patterns and principles and you would still not have clean code. So this course really focuses on what makes up clean code, not on all possible patterns and principles you could learn. Of course, there are some which matter a lot when it comes to writing clean code, and I will therefore cover them in the course, but some other principles are not as important from a clean code perspective. And there's one other differentiation I want to dive in, and that would be clean code versus clean architecture. We can also make a differentiation here. Just as with the patterns and principles, of course there is a connection. But clean code is really about writing, guess what? Clean code. It's about the code you write. Now, a clean architecture is about how you structure your project, how you separate your entities, how you store your data. It's, in the end, you could say where to write which code. Do you use dependency injection or not? These are questions you ask yourself when thinking about a clean architecture. And that's a different thing than clean code. And clean architecture also depends a lot on which programming paradigm you're following and which programming language you're using. With clean code, we focus on single code snippets, single files, you could say. With clean architecture, we focus on the overall project and how to model our data and how to distribute our code. And this course, therefore, is about clean code. We'll not focus on things like the repository pattern or anything like that, because that is not really related to clean code. It doesn't matter where you access your database, for example, from a clean code perspective. From a clean architecture perspective, that could matter, and you should therefore then take a dedicated course if that is what you're primarily interested in. This course will focus on clean code. I know we all want to get started diving into these sections where we learn about the different pain points and their remedies. However, you still have to be patient because writing clean code takes time. It's written over time, and of course, you want to write your best code right from the beginning. You're starting a new project, and especially after taking this course, you probably want to write the cleanest code possible right from the start. The thing just is, you will notice that you will always find ways of improving your code over time. You will never write the best possible code right at the start. Also, because your project, of course, typically evolves over time. You don't have a project which you just write once and where you then never need to go back to your code. You might need to fix bugs, you might need to add new features. And whilst doing that, you will change your code and you might be able to improve your code. So always question your existing code, and try to improve it. Refactor a lot, because refactoring is your key friend when it comes to writing clean code. Because when you write clean code, you typically start on a project, you plan your project, of course, the data entities you want to use and so on. But then when you start writing code, you implement feature by feature, but often you will then find a way of improving the feature you just worked on, and hence you refactor it. Then you continue and you find a way of improving that last feature you worked on. And this is a totally normal flow. Even once you're done with your prototype or your release candidate, you should review your code and then of course also again improve it where possible. So writing clean code is an iterative process and you're never done with it. You will always find ways of improving code, or as you add more features, you might need to change your code because it doesn't work with that new feature otherwise. So you should embrace refactoring. And I know from other courses that refactoring can be frustrating. I had students who really complained about the fact that we did refactor in my courses. The thing just is, refactoring is a totally normal thing to do during development, because you save time tomorrow if you refactor today. If you continuously improve and question your code, you will have better code tomorrow, which will speed you up tomorrow. In addition, a code base can really only survive and stay maintainable if you continuously question and improve and refactor it. Otherwise, it will not age well. As a pro tip, always try to improve the code whenever you change something in there. Even if you change something else, try to find a place in your code where you can improve a code, maybe improve a function, with all the tools you're going to learn throughout this course, because this will ensure that your code base is always healthy. Because there is a big danger. I'm of course aware that we're all always under pressure. There never is time to do it right. We just have to do it in some way. And therefore we are inclined to write quick code instead of good and clean code. However, consider this example made up plot, which is not too unrealistic. If we plot the amount of code output, so the code we write, the new features we add to a project, against the time for which our project exists, in weeks or months or even years, if we only write dirty code, and we just write code which works but which isn't really clean, we'll be able to pump out a lot of code and features initially, but over time that will decline because our code base becomes a burden and it becomes hard to maintain. And adding new features and fixing bugs becomes harder over time. And this is not some unrealistic made-up scenario. There are lots of projects out there which had to be rewritten from scratch at some point of time because they became unmaintainable, simply because they were not using clean code. If you are using clean code, on the other hand, you are slower initially, but over time you become more productive because adding new features is very easy in the future and you profit and benefit from your clean code. So that's why writing clean code is key and important, and why it should be a priority in any project you are going to start.